Hi, I'm Mike from the third semester on Medialogy 2013, and this is Image Processing HC 3 and 4, 30 filters in open frameworks. Let's just get started. This is my .h file where I keep all the variables and the structures, etc. First of all, we gotta have an open frameworks video grabber to put in the video stream so we can capture it. Then we have an Open Frameworks texture, and we actually have 7 of those. Those are going to contain the modified textures on the video stream in order to draw them out into the output window. Then we have an Open Frameworks image file type, which is just called myImage. It's used for alpha blending in the filters. You can see it later. Then we have 2 integers, one for the width and one for the height of the video stream for the output window. And then we have an integer that's going to be used for color depth filter, just called value. Actually, we could put this up down here with the other variables that are adjustable with brightness and gamma. Those are just going to be adjusted in the filters themselves, so they don't really matter at this point. And then we have 5 unsigned char pointers to contain the pixel arrays that we're going to get from the video stream, just called output A, B, C, D, and E. And then we have 1 char pointer called input A, which is going to contain inputs in some filters. And then I created the variables for some 2D arrays, which is going to contain kernels, different kind of kernels. We're going to apply them to some filters as well. I'm going to show you in a bit. Then we have some unsigned chars to contain the colors, RGB, and some unsigned chars to contain the result colors when the picture has been modified. And then I created 3 doubles. Those are just going to contain some new colors. Also, it's just used in some different contexts. Then I have an unsigned char choice, which is not really needed, but it makes the program flow a bit better, since this is used to choose between which filter you're going to add in the output window. So I'm not going to go more into that. Then we have an in pointer for a histogram I made. And this is actually not used for anything. Okay, so first of all, we start out by setting the cam width and the cam height, which is 320 and 240. Just quick on that is that the reason I did it this size is because that if it's bigger than this, it's going to contain a lot more than this amount of pixels when it's going to be RGB, since it's multiplied by 3. This is just for grayscale. It's 76,000, almost 80,000 pixels just for a grayscale image in this size. So if I wanted to go full HD, it probably wouldn't be able to do it, to run it quickly. So that's why I chose a small window. Okay, then we declare the variables that I showed you in the .h file. That's going to be brightness, gamma, and value. Just declare them here. They're going to be used for some filters. The value doesn't really matter right now. So let's just move on. Then here we grab the video and put it out to be put out to the draw window with the cam width and the cam height, so it knows in which resolution to capture it. Then we assign the output variables that I did before. Make sure that they are arrays, the pointers I did before in the .h file. We're going to create some arrays in them. These 2 first variables are going to be used for colored pictures, RGB, so they contain RGB, which is why they're multiplied by 3. And these are just for grayscale pictures, or in other words, they're going to be used for the illumination to change brightness, etc. Okay. So, and this is just the histogram array. I'm going to show you how it looks later. The video text These are just the video textures. This just pretty much just says that we're going to use those when we draw them out. They are going to draw out whatever is in the variables here. And these are going to be RGB colors, and these are going to be for luminance, and I created 2 more for RGB because I found out that I needed them later on. I also got an image in, the pic. This is just going to be used for some alpha blending in a filter. And this is just in the bin folder, in the data folder in the project. Then I have 4 kernels that I have applied in some different filters. We are gonna look at the mean filtering and the Laplacian kernels, the mean kernels and the Laplacian kernel. These 2 are for edge detection, horizontal and vertical. But I'll show you how it works later. And these are just to put them into arrays and make some variables that we can use in the actual code. So these just assign these kernels into some variables that we can use. Okay. Then here is the menu. These are just couts, they don't really do anything. You can just see how it looks. So you can choose which filter to apply. When the program starts up, just move on while it takes. And this is going to take an input. This is just the choice variable, and this is going to decide what filter we want to apply to the image. So here's the menu. As you can see, you just choose from one of those. Let's say we just, as we talked about the edge detection kernel, just press H down here and enter, and it should be applied here. Yeah, it's going to detect the edge. So this is how the program works. Let's get a bit more into the code. First of all, let's just start simple. I'm just going to go through some of the filters, not all of them, just the ones I feel like going through. Okay, first the invert filter. This will just invert the colors in the image, so light colors become dark and vice versa. And this is actually pretty simple code. First we assign a child pointer, create a child pointer called pixels, which is gonna grab all the pixels from the video stream input. And then we have a variable, an integer called total pixels, which is gonna contain the value of all the pixels combined. And this is because it has, the reason I multiplied by 3 is because we want a color image, so we get the so we don't just get a grayscale image. So this is going to contain the 3 layers, the value of the 3 layers of all the pixels in the image. So this is just running through all the amount of pixels that are in the image, all the intensities as well. And on the output A, we just have an array that is this is just gonna go through. We assign the output variable for each I value, so it's gonna go through how much was it, 280,000 or something, which is this folder is gonna run, and it's gonna, that means that this will go through all the pictures and it will assign the value of the pixels I, which means that the value that specific pixel has, it's gonna assign that. If I just remove this, it would assign the pixel value to the output, and then these 2 pictures would become identical. But since we take 255 and subtract the pixels value, which means that this specific pixel is going to be subtracted from 255, we're going to start from the other side, and therefore this would just be inverted. This is just, if for example that this has a value of 30, normally we would assign the value 30 to the output, to this specific output pixel, but since we're going to subtract it from 255, it's going to get the value of 225, which means that it will become lighter, since 255 is white and 0 is black. So that's kind of how it works, and let's just see if it works. It's pretty simple. The first filter, it's just a 1, and it works. Everything is inverted. Cool. Okay, so the next one is brightness for the choice 2, and same thing, same deal as before. We assign a char point of pixels to contain all the pixels, and then we have the total pixels again to contain the entire image with all the intensities, and then we go through it in the follow, which is going to run through all the pixels again, and then we create a new pixel, and this pixel is gonna contain the value of the pixel plus brightness. And as we know from here, as I told you, this is gonna contain the brightness of it. So if it was 30, if it was just this, it would become darker. Since we subtract it from here, it would become lighter. Unless it's less than half of this, and it's gonna become darker. So it's actually pretty much the same thing we do here. We just add some brightness to it. Since that it doesn't get any whiter than white, we could take this. This is just some code to make sure that it doesn't go below 0, which is black, and it doesn't go above 255. Then it's just going to be 255, and then it's just going to be 0. So it can't go into minus, and it can't go above 255, since it doesn't get any whiter than white and any blacker than black. And then we just assign the value of the new pixel to the output pixel again, and then here, I forgot to say that before, that here in the video texture we load the data. We load the data from output A, which we assigned to the new values of the pixels on each pixel, and then we take it with the camera width and the camera height. And here we just say that it's an RGB image, so it has to look for colors as well. Okay, and this is simple brightness. I actually added a little something to this. We're gonna see. We're just gonna see if it works, and I'm gonna explain something about the output. And there we go, 2, boom, and it's brighter here. Actually, if I press D, it's gonna get darker, and if I press A, it's gonna get brighter. I'm gonna show you how. Well, all the way down here, in the end, this is just what does it. It's because, as I said, it's a variable that we can change, and this just adds a float every time I press A, and it subtracts 1 from brightness every time I press D. So that's why it gets darker, because it gets lower value, and it gets a higher value if I press A. Okay, let's just go through this quickly. First of all, offset color, it just sets the background color. No, that's a lie. It just states that there is colors and this one will output the entire the normal video stream in normal, just as it is captured in the webcam. It's just drawn on position 0.0. Here is the thing that matters. This is the textures that which are modified, and these will just be positioned in the 2 first here, camera width, since it's going to have to be positioned next to this one. So it's camera width that's 0 because we want it on top as well, right next to it. And then it's going to have the size of the camera width and the camera height. So it's just the same size, but it's positioned 1 camera width away from it. And these are pretty much the same down here, all the way down. These are a bit different because they're cropped and resized, but we're going to get to that. And this code here will just draw the histogram, but we're going to show that. I'm going to show that in a bit as well. Okay. This is the first video. I'm gonna upload the second part in just a second.